Ever wondered how you can hear your friend's voice from across the room? Or how music travels from speakers to your ears? Today, we're diving into the amazing journey of sound. Sound is literally all around us, shaping our daily experiences in ways we often take for granted. Let's uncover the fascinating science behind how sound travels. Sound begins with vibration. When something vibrates, like a guitar string or your vocal cords, it causes the surrounding air molecules to move. Imagine throwing a pebble into a pond. Just like the ripples spread out across the water, sound waves spread through the air in all directions. These waves are created by molecules bumping into each other, like a perfectly choreographed molecular dance. When something vibrates, it pushes nearby air molecules together, creating areas of high pressure, followed by areas where molecules are spread apart, creating low pressure. These alternating areas of high and low pressure form what we call sound waves. Think of it like a crowd doing the wave at a sports stadium. The wave moves through the crowd, but each person only moves up and down in their spot. Similarly, air molecules move back and forth as sound waves pass through them. But sound doesn't just travel through air. It can move through any material that has molecules that can pass energy from one to another. That's why you can hear underwater, or why you can put your ear to a wall to hear what's happening in the next room. In fact, sound usually travels faster through liquids and solids than through air, because the molecules are closer together. When these sound waves reach your ears, they cause your eardrum to vibrate. These vibrations are then transformed into electrical signals that your brain interprets as sound. It's like having a tiny biological microphone inside your head. The speed of sound in air is pretty impressive, about 343 meters per second at room temperature. But that's nothing compared to how fast it travels through water, 1,480 meters per second, or steel, 5,120 meters per second. Sound can't travel through a vacuum, though. That's why in space no one can hear you scream. The louder the sound, the bigger the vibrations. And the higher the pitch, the faster the vibrations. This is why a deep bass sound can shake your windows, while high-pitched sounds seem to pierce through the air. Understanding how sound travels helps us in countless ways, from designing concert halls with perfect acoustics to developing better headphones and speakers. Next time you hear your favorite song or chat with a friend, remember the incredible journey those sound waves are making to reach your ears. It's a constant symphony of molecular movement happening all around us every single second of every day.